there's my little jingle for you. All right. So we're moving on with our Unit 4. Okay, integer exponential definitions. So I'm moving down to the middle portion of the first page where we have our definitions, some basic definitions and rules. So first one, b to the n power, that just means you rewrite b however many times n is in the power. B to the 0, anything to the 0 power is 1, no matter what it is. Anything to the 0 power is 1. Now this is a key one. Okay, you have b to the negative n. So what we do is we go here first. 1 over b to the n, because you want to make it a positive exponent. And then this b to the n is just like we did in rule number 1. You just rewrite the b the n number of times. Okay? Now, of course, when you get into these exercises and it says without using your calculator, that's just basically so you understand where the solutions are coming from. You will always be able to use your calculator. So if I gave you the exponential function, f of x is 20 times 2 raised to the x power, you can, of course, put it in your calculator, put it in the graph, or use your such that. For mathematical sakes, if I have f of 2, I would plug it in as 20 and then 2 raised to the second power because x equals 2. Order of operations, you would do your exponents first. So I have 20 times 4, which is 80. So that's the mathematical computation. Now all these other ones, you don't have to show me every single time, and of course you can use your calculator. So you can try these, put the such that, or put in the graph, and this gives you 20, f of 0, f of negative 2 is 5. But if they ask you to expand on your knowledge, it says if when x increases by 3, by what factor does y increase? Explain your answer. So now you have to logically interpret what's going on and validate or explain what's going on as well. X increases by 3. So if we have x equals 0 and we go to 3. Okay, so we're going to say f of 3. So that means we started at 0, now we're going up to 3. By what factor does y increase by? So we have our equation 22 to the third power. So order of operations, you would do this first. So 20 times 2 to the third power is 8. So 20 times 8. So what factor does y increase by? By a factor of 8. Okay. Now, we're moving on to exercise 3. Multiplication with the same base, and we have powers. So if you need to, hopefully you don't, if you wanted to rewrite it, and I'll show you this once. 2 to the third is 2 times 2 times 2. 2 to the fourth is 2 times 2 times 2 times 2. So how many 2's are there? There are 7 2's. So it is 2 to the 7th power. So we want to write, for each of the following, write the product as a single exponential expression. So we're not evaluating, we're leaving it as a single exponential expression. So what other way could you get 7? By adding the 3 and the 4. So when I look at the second one, B, I have 2 to the 6 times 2 squared is 2 to the 6 plus 2, which is just 2 to the 8th. Done. 2 to the m times 2 to the n is just 2 to the m plus n. That's like a rule. Okay, you would have a rule for all values of m, all values of n. So I'm hoping this is review of exponents and their properties. If not, make sure you stop me in class. We can go over a little slower. But like I said, this should be a little review. Now, exercise 4, the product. 2 cubed times 2 to the negative 1. It's the same process. You're multiplying, and you have the same base. Just be careful of signs. So we want to write as a single exponential expression. So again, as an exponent. So we have 2 to the third plus the negative 1, because it's the same base. So then we have 2 raised to the 3 plus negative 1, or just make that 3 minus 1, 2 squared. And that's it. Now, it says evaluate 2 cubed times 2 to the negative 1 by first rewriting 2 cubed and 2 to the negative 1. And I think this rule for the negatives is on the previous page, rule number 3. So 2 cubed is 8. 2 to the negative 1. Remember, that's on the previous page, b to the negative n. And that's times 1 over 2 to the first. So that's rewriting it. Now, if I have 8 times 1/2, that just gives me 4. And it says in part C, do the answers A, B support the extension of the addition property to the negative powers? So it's just saying that, can I find the same solution of 4 using the exponent law or rewriting as the powers? Okay, and it gives you the same answer. So now the next exercise, if we have a power to a power. So if you wanted to rewrite it like we did in the one of the previous exercises, it would be 3 squared times 3 squared times 3 squared, because it's 3 squared to the third power. And then using our previous knowledge, we would add, because you're multiplying the same base, so you add the exponent, so you get 3 to the 6th power. Okay, right as an exponential expression. So how do I get the 6? I do 2 times 3. Okay, so you're multiplying. If you have a power times a power, you multiply. So in the next one, I have 3 to the 4th raised to the 2nd. It would be 4 plus 2, which is 3 to the 8th. Next one is 3m to the n power. It's 3m times n. And that's it. You just leave it like that. Okay? So if you have a negative, it follows the same process. If you wanted to, you could do the power to the power and get 3 to the negative 8. And that would be rewritten as 1 over 3 to the 8. Okay? And it says show this expression. So, but what they wanted you to do first was rewrite 3 to the negative 2 in fraction form. So 3 to the negative 2 in fraction form would be 1 over 3 halves raised to the 4th power. And then, if you were to evaluate, you would have 1 to the 4th power and 3 squared to the 4th power. Well, 1 to the 4th power is just 1. 3 squared to the 4th power is 3. Power to a power you multiply, so you have 3 to the 8th power. So that, if you do it either way, it will work. All right, I'm also going to move on to lesson 2. So we're going to go take a look, all right, at lesson 2. All right, a little music for you, because it's just a continuation of the power, okay, the power to a power. So if you look at these in exercise 1, and if you had to pause the video to find out where you are, that's fine. So we have 2 third power raised to the 4th power. Remember, 2 to the 12th. Multiply. And then we have the next one, B, would be 5 to the negative 10. The next one, letter C, is 3 to the 0. 7 times 0. Oof. Look at the next one. Little tricky. Okay, do this first. So you have a power to a power to a power. So then I have 4 to the negative 4 squared. Okay, which then gives me 4 to the negative 8. So that was just a quick little review. Now we're going to look at fractional exponents. So apply the product property to simplify. So if I have 1/2 squared, so 1/2 times 2 is 1, so that just gives me 16. Now what other number squared yields 16? So what times itself gives you 16? It would be 4 squared. So now we can say, in part B, 16 to the 1/2 is equivalent to what more familiar quantity? Well, 16 to the 1/2 is the same as the square root of 16, which is 4. Where does the 1/2 come from? 16 to the 1st power, square root. So you can change a fractional exponent to a square root. And that's what it says here. This is remarkable. Okay? Now, test the equivalence of the 1/2 exponent using your calculator. Now, you don't have to do the square root button. You can go to your calculator and just plug in 25 caret, go to your fraction button, 1/2, enter, and there it is, 5. So like I said, you do not have to change anything. So we can just leave it. So we have the square root of 25, 5. Square root of 81, 9. Square root of 100, 10. Or 25 to the 1/2, 81 to the 1/2, and 100 to the 1/2. So here is your rule right here. So for any fraction, you rewrite b 1 over n is the same as the nth root of b to the first power. So that is a very important rule that we will use throughout the whole year. Now when we get to the next part, we have more fractional exponents. Of course, again, you can put it right in your calculator, 125 to the 1/3. If they want you to change it, to rewrite it, it would be all based on the square root, okay, the b to the 1n. So there is your b, okay, square root. There's your 1, there's your cubed, okay? So it says rewrite following using roots instead of fractional exponents. That's how you rewrite it. And then you can put it right in your calculator. The third root of 125 is 5. 16, 1, 4. The fourth root of 16 is 2. Now what we have to do here, you got to be very careful with the negatives, because first we have to rewrite it as 1 over 9 to the 1/2. So the 9 to the 1/2 is 9 to the 1, and there's your square root, equals 3. So it's 1/3 is your answer. 32 to the negative 1/5 is 1 over 32 to the 1/5. So we have 32, 1/5 like that, and that equals 2. So 32 to the negative 1/5 is 1/2. Again, if I'm going too fast, you can pause it, you can slow it down, trying to get into 15 minutes for you. Okay? Now, when we're thinking about the expression 4 raised to the 3/2 power, fill in the missing blank and evaluate the expression. So if we have 3/2, and we already have the 1/2, we feel like the base of 4, and we're missing the 3. So that means that we have fill in the missing blank, so we have 4 to the 3rd power to the 1/2 power. So then you would do 4 to the 3 times 1/2, which is 4 to the 3/2 power. Okay? So if you wanted to evaluate, you could very simply put in your calculator 4 to the 3/2 power, and then that would give you 8. Now, the other way it could do this is I have the 3 already, so then I would write it as 4 to the 1/2. So 4 to the 1/2 power raised to the 3rd power is 4 to the 3/2 power. And then if you want to say 4 to the 1/2, oh, that's 2. 2 cubed is 8. Or again, put it right in your calculator. Power to a power. And that's what letter C says. Okay? Using both A and B, evaluate in your calculator. Now, again, without using a calculator, you can always use your calculator. Okay? So, if it says without using your calculator, it would be 27 squared, and then you have a cube root. All right? But that can also be written as 27 to the 1/3 power squared. And I know you might not know your cube roots yet, but we'll practice with them. They'll become more familiar. So the cube root of 27 is 3. 3 squared is 9. And if you put it in your calculator, 27 to the 2/3 would give you 9. So what I want you to do is, here's the rule right here. Okay, b to the mn power is the nth power of b to the m. Okay, and what you're going to do to hand in on Tuesday, ready, hand in on Tuesday, exercise 6, A, B, and C. And you're just going to put it in your calculator. I'm going to give you a note card, and you're going to have like 10 seconds to do it. Okay, so that is what is due when you come into class. Okay, so make sure it is done, ready to go. All right, look at that, just under 15 minutes. See you in class.